finding security vulnerabilities in a language I built, which would amuse me very much on some level, but also be super annoying.
You're listening to Marianne Writes a Programming Language. And I'm Marianne. Oh boy. I'm back. It took me longer than I thought it would to finish user testing the pre-alpha version of Fault. Partly that was scheduling. Partly that was wrestling with design issues highlighted by the user testing itself. But that's good because that was the whole point, right? I conducted two different types of user testing. The first was passive. They logged every time someone used the REPL. Just logged the spec before parsing it. About 50% of people ran an example model without any changes, just to see what the code looked like and what the output was. Then 20% ran the same model again with a minor tweak, usually changing a single value and seeing what the difference was. Only a few people attempted to build their own models. One person decided to lint an example model, keeping the significant values the same but removing white space in certain areas. That kind of amused me, actually. This data was useful and will continue to be useful in its own way. The second type of testing was pairing with people who volunteered and either writing a model or going through the documentation with them and asking them questions about how they expected pieces of code to behave. This was really useful, but sometimes frustrating because I often wanted to put different options in front of them and say, well, how about this? But for a lot of the issues they raised, I did not actually have good alternatives available. So I got what I needed out of the conversations, but I couldn't help feeling like I could have been better prepared for them. The first problem that, truth be told, bugged me a little going into the test and continued to bug me more and more every time it was mentioned is the required parameters of the stock flow objects. If you recall, you must define a name and a value with a stock and a function with a flow. But in the same key value block, you can also define any number of custom properties. There are different rules for these special properties with the reserved keywords and the user-defined properties. And sometimes special behaviors. Functions can be initiated with the starting value so that you can reference historical outputs of the function in the function itself. One person used this to write a Fibonacci sequence in Fault. But you shouldn't do that with the flow's default function, which is confusing. Why is the behavior different? A function should be a function, right? A precedent is a special, non-required property of flows, but it must be an int value. A name property of a stock must return a string somehow. I told myself going into testing that all languages have special reserved keywords and built-in functions with specific parameters, but the more I worked with people interacting with the language for the first time, the more it felt clumsy and brittle. In the case of flows and their default functions, this created a weird, redundant syntax. Okay, we want a reserved keyword to represent the flow's function. FN for function seems logical. But, wait, since functions themselves are declared with the word function, followed by a set of curly braces, that means...
When I saw FN and then function, I was like, oh, that's function, and that means function.
Yeah.
So, and I don't know, is this sort of like a key value pair, or is this mean this is the function and this is the property? You know?
Yeah. This is like touching on like one of the things I've been exploring and kind of like meditating about.
Cool. The input flow then is taking as a target the queue, and its function, again, function seems special here. That's another one of my notes. If flows always have a function, like, is this a keyword really? Or are there other function names? Or what's the thought here?
Sure.
I need to figure out how to simplify things. It's true all languages have these little quirks, but typically they develop those quirks over time as they change direction and attempt to maintain backwards compatibility. It seems stupid to start off with so many quirks from the beginning. Then another problem I picked up on while preparing the test exercises themselves is if you opt to write a model, the task I would suggest is modeling a message queue, right? There are a couple ways you could approach thinking about a message queue as stocks and flows. You could think about the number of consumers and the number of publishers or producers as themselves stocks. Or you could think about the messages themselves as a stock and the movement of the messages from a queue to either a sent, received bucket or a retry queue as a flow. Except, how do you change which stock the flow is sending data to? There's certainly conditional logic in fault. That part is easy. We can do if-else sort of control flow. But the flow has one source and one target stock maximum with no side effects. So you either try to change the flow's target stock dynamically, which I'm not actually sure would work, or you have to build a way more complicated model that doesn't really map well to the behavior you're trying to represent. You end up painting yourself into a corner.
So then producers have a value. This is another thing I noted here, which I'm sure we can talk about later, but value seems to be special. It's definitely special within the REPL, but is it special overall is kind of my question. It also seems to be special overall because of the way target and source work.
Yeah.
Because they implicitly change that dot value.
Yeah. So this is something I've been going back and forth on rather regularly. Basically, the idea of can you assign, how do you do assignment as an output of a function, right? So effectively, the function of a flow assigns values to the value property of the stock it's connected to, but it doesn't have to be that way, right? Mm-hmm. And there are various places where, as I'm trying to like work through models for my own tests, I think like, oh god, it'd be so easier if the flow could like send this value over here and send this value over here. So it could definitely, like with some fairly minimal retooling, develop the syntax and the logic to sort of say like this value gets sent over here and it's now assigned to this part of the stock, and this value gets sent over here and assigned to this part of the stock. The thing that keeps me from doing that is kind of not wanting to move away from these very tight, pure functions that only really do one thing and a factor change one thing, right? Mm-hmm. So that's the part where I'm like trying to figure out how much utility do I get from giving that level of flexibility where it's not necessarily value that's changing. You can have the function of the flow change other things and therefore build more complex and like lighter weight models versus adding a level of like state change chaos to the overall model. Right? Because it is a bounded model, but it is still potentially, as the model grows more and more complicated, it gets more and more computationally complex, totally. Right? Yeah. So I'm still struggling with that. I think what I will probably end up doing is testing out that kind of delegation and seeing how I like it. And then maybe running some more tests with people and seeing what kind of chaos it opens up if we try to build a really big model. Mm-hmm. But yeah, so noted. So that's really why value is this special thing that doesn't behave quite the way the other properties behave.
Sure.
Then on top of that, Fault tries to draw conclusions about what you want to do with the value produced by the flow that, in retrospect, might have been confusing.
The source is the queue size. The pool is now the consumers. Yep. And that they're going nowhere. So I want to create a new value which goes from 0. This is kind of related to the same thing. Yeah. I guess the new value goes from 0, even though it's got no target. Is that the right way to think about it? Or
Yeah, because
The
so
target
if
is always a
there's
constant 0.
if there is a source value and not a target value, it will essentially treat the source as if it is the target value. It's just at this point, it's just syntax to make it like clear for people's heads rather than like what the code is doing, right? If there's only one stock it's connected to, it will do the same thing no matter if it's targeted at the source. It only changes its behavior when there are two stocks on either side.
I see. Didn't realize that. Because it feels like source is being subtracted from and target's being pulled from.
Right. Well,
I changed it here.
That is of course the idea of it. But if you were to connect a flow to a stock as a source, but the output of the function was a greater number than the source, like it incremented the source, it would just increment the source. It wouldn't go, hey, wait a minute, this is supposed to subtract from the source. You're supposed to be flowing out. It just did not seem worthwhile to be like that picayune about it, but it did seem worthwhile to sort of help like people would think about it in terms of this is the source and this is a flow out of the source, and to be able to allow them to define it that way if they so wished.
Sure.
Okay. So what to do about this? Well, first, if I allow the function to explicitly assign values to stocks, then having special keywords for source, target, and value is unnecessary. You can declare a flow with stocks assigned any key name you like and change whatever property of that stock you need to. That one change adds a ton of expressiveness and eliminates 3 out of about 5 required reserved keywords. The stock name itself is unnecessary because the statement where you declare it already gives it an identifier. So that's down 4 now. That leaves the function problem. It took me a long time to figure this one out. Sure, I can make the reserved word something like rate and eliminate the ugliness of the repetition of the word function, but that isn't really satisfying. It's still a special property with slightly different behavior than identical looking properties elsewhere. I spent a lot of time pondering different ways of arranging blocks of code to separate out this one special thing in such a way that its different behavior could be anticipated. I spent a lot of time on Rosetta code looking at different syntaxes from different languages, hoping for inspiration. If you're unfamiliar with Rosetta code, it's this great site that displays versions of the same simple programs in different languages side by side. An amazing resource if you want to think deeply about design patterns and programming language grammars. Then suddenly, while doing something else, the answer hit me. And it was one of those situations where once I thought of it, I was shocked it took me so long to think of it. The reason why the function block seemed necessary is because fault has no syntax for call expressions. When a model runs, it needs to know what function it's executing. I was using a special keyword to determine that, and then adding additional special optional keywords like delay and precedent to configure what the model does as it runs through a single step. All that logic is abstracted away from the user, and then the special keywords expose those configuration options back. Why on earth was I doing that? These are programmers, right? Why don't I just let them program what the model does in a single step? Yeah, like I said, obvious. So, in addition to changing flows to allow them to assign values to any number of different stocks, I added something I'm calling a run block. At the end of every model is an optional configuration statement that reads 4x run all. I say optional because if you remove that line or never add it in the first place, the model still executes all of your flows in a 5-step model by default. But if you change the statement, you can make fault run part of the model or run as many steps as you'd like. Now, instead of run all, the proper syntax will be run curly braces followed by a definition of what's happening in each step. If you want to write a delay, you just write a delay as a conditional in that block. If you want to change the order flows execute, you change lines of code in that block. And you can call the function in the flow object whatever you like because you call the function you run from that block. Of course, the trade-off is that you can produce something in fault that is not a true stock flow model if you want, but maybe that's not as damning as I would have assumed. In my user tests, I spent a lot of time talking to programmers of various skill levels, but there was one other group I wanted to chat with before I concluded my testing. People who actually write system dynamic models today. To close out my user research period, a few weeks ago I sat down with James Houghton, a researcher at the University of Pennsylvania, who teaches college students how to build models and has also created a suite of tools to run those models in Python. So I always thought of SD as like being almost niche to the stock flow abstractions.
Yeah.
But it sounds like for you, it is broadly modeling these kind of sociodynamics as a whole.
Yeah. You have human actors with behavioral, realistic decision rules that are interacting to create some phenomena that doesn't exist in the individuals themselves.
So that being said, how do you pick your model constructs, right? Like, how do you decide this fits best with an agent phase, this fits best with stock flow, this fits best with some other construct?
Yeah. There's two sort of tools that you can use for thinking about that. One is the level of aggregation of the model, or its scope. Like, what do I want to stick in the model and what are the boundaries? And the other, so that's sort of like capping a top line on the scope of the model. And the other thing you want to think about is the granularity of that you want to represent. And so in this case, I needed to get granularity all the way down to the level of not just the individuals, but the individual beliefs within the individuals. And so for me, that made it an agent-based model. But I have a very good friend who's modeling the COVID epidemic, and his models are compartmental because the questions that he's asking are more at the top level about the society as a whole. And so in that case, you can create these aggregations, the stocks of individuals, and represent these groups of people as a single number. And it works.
This is so fun because this is weirdly intersecting with something else I'm doing in my work environment around programmers' intent, right? Because like I think the core issue with specification on the technical side is that you are never going to write a specification that is 100% accurate to every conceivable factor in a system, right? So at some point you have to make a decision of the level of detail. Yeah. But that like always drives computer people crazy because they want absolute truth. Sure. And they like this idea that I can write the spec and I can prove that it's correct. And that's objective, not subjective. And so there's this question of like, how do you reliably set those boundaries of like what level of detail you need? And so connecting it to, well, what research questions are you asking of the model? It makes a lot of sense, but it's also not an answer that my community people like because they want to share models and reuse them and build on top of them. And it's like your research questions are not in line with somebody else's research questions, and you can't reuse their work, right?
Yeah. Well, I think the most important thing in modeling, and probably in academia as a whole, is to really know what question you're asking. Yeah. And when I read an academic paper that doesn't really hang together and I can't understand what it's saying, often the reason is that the question isn't clearly articulated and possibly isn't clearly understood by the authors. And the same is true when you look at a model. And if it has a whole bunch of pieces and you're not really sure why they're there, maybe the reason is that it was unclear why this model was being built.
Yeah.
And so the best models are the ones where you can really clearly articulate exactly what the research question is.
Sometimes I think there's a certain magic to having specific conversations at specific times. I don't always work on this project as diligently as I could. Another secret reason why it took me a bit longer to finish user testing than I thought it would. I feel like I have to sit with things sometimes, waiting, not exactly for inspiration, but for something. As it happened, I procrastinated on reaching out to James for, about a month. I don't know why. I just kept putting it off. And as luck would have it, by the time I did reach out, I was in the middle of exploring approaches to capturing programmers' intent for a completely different reason. Right now at work, I'm working with a team to build new technology, but of course, I'm coming from a career of slaying dragons of technical debt on existing systems. Naturally, I can't build a new system without thinking about how functionality will drift over time, how documentation will fall out of date, how more and more lines of code will make it harder and harder to onboard new engineers. There's some interesting research around formalizing programmers' intent into the code and some theoretical work around compilers that can identify when a function violates the programmer's stated intent. Had I not waited, these comments in this conversation probably would not have stood out to me the way they did. And that's a stroke of luck because I think they reflect something critical about fault design that I hadn't put much thought into. A model's scope and assumptions are defined by its research question. Ergo, the thing that a spec has to communicate most clearly is not how the thigh bone connects to the leg bone, but what the intent of the model is. Assertions have been part of false grammar from the beginning, but I was mainly thinking about them in terms of simple Boolean statements like x is greater than 5. Yet, just as it is my habit to read the unit test first when I try to figure out a new code base, these assertions will broadcast information about the programmer's intent. It's going to be important to invest some time and energy into figuring out how to emphasize their significance, and I don't have a good answer for that right now. Something that came up in our chat that genuinely surprised me is how, from James's perspective, the characteristics of visual programming compiling to code wasn't just a crutch for silly non-technical people. His tools don't convert to Python to remove the proprietary software used to build the models. He wants to keep that drag and drop stock and flow diagram stage in the process. This caught me off guard because I find being given a visual abstraction that maps to auto-generated code frustrating. I'd much rather open up the hood and write the code directly. I assumed all people who programmed felt the same way.
The thing is, the stock flow models, the diagrams themselves, are actually, think about it like a technology in a way, in that this is a tool that we can use to think about the structure of systems. So everything that's represented in that stock flow diagram is just something you could represent with math if you wanted to. But by structuring it with the stock and flow diagrams and the feedback loops, you see the structure of the system in ways that you don't see when you just have lines of code on the screen. So mathematically, they're equivalent, but in terms of your understanding of the system, you do a lot better when you have the visuals.
Is the value of these tools actually the visual? I'm sort of was approaching it probably too much as a programmer and seeing the value of the tools being the interface of code basically giving you shortcuts, right? Where it's like, okay, this understands what a stock is, understands what a flow is, and like makes it easier. You have less code to write because there are some built-in like syntactic sugar that makes it easier to get to that place. And then when I actually look at the code, I'm like, no, this is just like, you could do this in any language, right?
Absolutely.
You really like the visualization and like maybe some graphing is why these tools are popular?
It is, exactly. And these diagrams are a tool for thinking about the structure of complex systems. Once you have them built, you can translate them to any language you want, and the math will work just the same.
The programmer in me stubbornly insists that I can probably understand a system better from looking at code. And yet, reading code is so much harder than writing it. Perhaps visualizations do make it easier to communicate general information about a system.
The writing down of the equations is the easy part. Totally honestly, the understanding the structure of the system well enough that you can write down equations that accurately represent it is really difficult.
Yeah.
And what's dangerous is that it doesn't look difficult.
Yeah.
When it's done well, it becomes really clean and easy to understand. And that's when you know that a real master has been doing their craft there.
So, okay, I have a few more design questions that I need to develop answers to before this journey is over. Number one, I need to figure out how best to present assertions so that they are treated both as tests and as a documentation of the programmer's intent. Number two, I need to figure out how to incorporate visualizations into false output. The prototype would generate a .viz flowchart before running your model, and I found that to be really helpful. I still don't like programming via visual methods, but when I'm building alloy models, the ability to check what alloy thinks my system looks like is often the best debugging tool. And finally, in general, I need to think about how a person interacts with and understands a spec someone else has written, and how the code arrangement makes that easier or harder. Then there was this one other key challenge that this conversation highlighted for me.
What are the common mistakes that people make when they're building models?
There's a lot of things. I'd say the biggest ones are not really being specific about what they mean by their stocks and flows. So that's in some ways it's a conceptual sloppiness, where you haven't gotten all the way down to what is it you really, really, really mean here.
Yeah.
And then there are just some mathematical mistakes that are easy to do. An obvious one is that if you have a stock with an outflow, the stock is something that you think about like water in a bathtub, it can't really go negative. You need to be able to check that it hasn't gone negative. And so what you need is a feedback between the level of the stock and the outflow. And so we'll call that a first order control on the outflow, so that you don't go negative when you shouldn't.
Right.
And if you forget that, it'll work most of the time until you get to some edge case where your stock has gone negative and you didn't notice, and then all of a sudden you get really, really strange behavior.
So, but like, I almost like instinctually want to think about this as a type system issue, right? Like if you have a particular stock that cannot go negative, that's something that can be reasoned about through type systems. You could sort of say this is a characteristic of this type, that it never is negative, and then possibly reason about it on the compiler or at runtime with that thinking in mind. This is the problem with mixing multiple interests. They collide in strange ways sometimes.
This is the power of mixing multiple interests.
Perhaps. We'll see.
You've been listening to Marianne Writes a Programming Language. A transcript of this in every episode is available on the dev community. Just go to dev.to/Belmar to find them. That's dev.to/BELLMAR. There's also a fair amount of bonus content available to supporters, including the full interviews with the guests from this week. Here's a preview.
Thinking about stock flow models, like what are the common constructs that people use in those type of models? Like so stocks and flows, obviously, and then delays. Are there other constructs that tend to show up in models from people?
There's a lot of patterns. You get a lot of archetypes. So, a balancing feedback loop with a delay, right? And when you see this, there's certain sort of behavior that you expect to come out of it. So when you have a balancing feedback loop with a delay, that's when you get oscillations. And so you can start to see just from the structure of the model a little bit about what its behavior might be. And vice versa, when you see a time series behavior that has oscillations in it, it makes you start to think, maybe I'm going to start looking for this sort of structure.